Hey guys. Sorry, just reading my I'm just reading through some of the last comments that's been coming through my MCAT videos for 2021. Right. October. So here's something interesting, since you guys are actually here. The MCAT is also an exam in the US. I think it's for the medical exam. So I've just got like a whole heap of comments popping up on the our New Zealand MCAT, where people are talking about doing the MCAT. There you go. Hey Charlotte. Hey Lolly, how's the snow trip, man? You guys were lucky. I could imagine, man. It's good to hear, good to hear. Hey guys, if you're just joining us, I think we're going to go through the last question, question 3 of integration. And then after that, I'm going to try and do this in like 40 minutes because I'm pretty much running on fumes at the moment. Had a very long day and I'm just about to crash. Hi Civics, welcome. So usual, what I'm going to do is I'm going to give you guys a bit of a starting point. So let's say we're going to start going through the answers for this question. What should I say? Yeah, let's actually go with 805. Nah, 804. Let's go with 804. And we'll actually go through the answer at 804 for this. I feel kind of stink, you know. It's like all these people are coming and watching these videos and it's got nothing to do with the medical exam, but rather the level 1 algebra exam. And some of the comments are like, yeah, like serious, man. Also guys, just a bit of a heads up, next week I'm going to be doing a bit more level 1 streams. Charlotte, like, to be honest, there's a person that's actually messaged on the level 1. I'll actually show you guys. It's can I show you guys? Yeah, I can. Hang on. Just see this. Yeah, check out this. I hope I can pass the MCAT. Don't have a job. I'm 36 years old. All my dreams later to MCAT. I really feel like they're talking about the MCAT in the medical exam in America. Surely there's something like that. Anyway. That is what it is. Alright, so guys, I'm gonna start recording these questions at the same time, so I'll kinda go through this as well. Ravin, do you actually speak Spanish or do you just say hola amigo? ¿Hablas español? No? Or is it just hola amigo all the time? Love it. Absolutely love it. Alright guys, I'm going to go through question 3A here. So I'm going to record, so probably we'll be skipping away from the chat for a second. But I'll be back, alright? So we've got question 3A here. With question 3A, the first thing you really want to be doing is expanding the brackets, because we've got that square root of x that we need to deal with. So I'm going to have x plus square root of x times x plus square root of x. Then I'm going to actually do expansion of a quadratic. So I've got the first terms, the outsides, the insides, and the last terms. So what I've got here is x squared. Now x times x to the power of half can be written as x to the power of 3 over 2, because x to the power of 1 plus x to the power, like, times x to the power of half. So 1 and half makes 1.5, or 3 over 2. We've got another 3 over 2. And plus square root of x times x is just going to be x. So what we have here is x squared plus 2x to the power of 3 over 2 plus x. And of course, we have got to integrate this. Now, in saying this, like, this is just expanding the bracket, so there's actually no grades here so far. X squared integrates to x cubed over 3 plus 2x to the power of 3 over 2 plus 1. And of course, that's going to get divided by the new power, which is 3 over 2 plus 1. Of course, I've got to put that 3 here. And of course, we've got plus x squared and the new power divided, so we've got to divide by the new power, which is going to be 2, and plus c. Now I'm just going to tidy it up a little bit. You can kind of leave it to a degree, you can kind of leave it like this, but yeah, you know, tidying it up is always a good idea. So I might even put like a little bracket here. That's pretty much it, guys, and that should get you an achieved. If you do want to tidy up that middle term, you can, because you're going to end up with x cubed over 3 plus 2x, 3 over 2 plus 1 is 5 over 2. You've got 5 over 2 plus x squared over 2 plus c. Of course, you're really wasting time, you know, by actually doing this. So we're kind of gonna, I mean, I'm just doing it because I know sometimes people are like, why is this, how does this answer actually work? So the 2 comes to the top. We've got 4x to the power of 5 over 2 over 5 plus x squared over 2 plus c. But really, all you need to get up to is that part there to actually get an achieved. This is not a masterclass demonstration, man. This is more of a person that's extremely tired at the moment and just wants to go to sleep. But I made a promise to deliver question 3 to you guys and finish integration. So we're going to finish this paper today. Right. Any questions with question 3a? Are we ready to move on to the next question? What's up? I like, see, this is the thing I always go, you know, some of my kids actually come here. Do I call them by their YouTube name, or do I actually call them by their real name? All right, let's go to question 3b, and I'll put it up and then we'll have a yarn. Oh, I honestly hate trapezium and Simpson's rule. The reason I hate it is because it's like, you just got this long equation that you got to substitute and you got to try and figure out what the answer is. It's so frustrating, and I can't believe, like, you know, some people like put it wrong in the calculator and get it wrong, and it's just like, ugh, God, it's annoying. Anyway, calculus formula sheet. Let's get it out and have a look at it. If you guys got the formula sheet in front of you, you can kind of just get going with it. Otherwise, what I will try and do is I'm going to try and see if I can fit this window. Add source, desktop capture. There we go. I mean, that's pretty much your trapezium rule, guys. All you got to do is just substitute the values and actually work it out. Super frustrating, because it's like, I always get annoyed with this question, but that's me. I sometimes just skip through this question, don't even bother with trapezium rules. But anyway, let's actually do this question. So as I mentioned before, trapezium rule, you've guys got to, it's just a matter of substituting the right things, all right? So what we're going to do is we're going to write that equation down first. I've got b and a. So in this case, b is equal to 2.5 and a is equal to 1. So put those two things there. And then it's approx f of x dx, whatever. F of x dx is equal to half h. Now, if you guys have a look at it, h is pretty much that, like, what the interval is, right? So if you go 2.5 minus that is 1.5, and then divide it by 1, 2, 3, 4, 5, 6. So it's about 0.25. So h is equal to 0.25. Because, like, n is the number of gaps that you actually have between them. And you can see that there's actually 1, 2, 3, 4, 5, 6 gaps. So h is equal to 2.5 minus 1 divided by 6. All right, which equals to 0.25. We already kind of can see that here because everything is going up by 0.25. So that's what h is going to be. So that's going to be 0.25. And then what we've got is y0. So this is going to be y0, y1, y2, y3, y4, y5, and y6. Every time I say y5, I always have a good little laugh. But all right, what's y0? Y0 is 0.8 plus yn, which is y6 in this case, which equals to 2.4, plus 2 times everything that is remaining. And of course, I ran out of space. That's okay. I'm gonna try to carry it here. Plus 2 times 1.1 plus 1.5 plus 1.9 plus 2.2 plus 2.1. So it's just a matter of putting this in the calculator, guys. I guess I just need to get rid of this. I don't really need this screen anymore. Or do I? I'll use it later. So putting this all in the graphics calculator at the moment. So what I've got is 0.5, 0.5 times 0.25 times bracket 0.8 plus 2.4 plus 2 times 1.1 plus 1.5 plus 1.9 plus 2.2 plus 2.1. First bracket, second bracket, that should be done. And I get an answer of 2.6. I mean, if you look at it, I nearly worked on this question for 3 minutes. For an achieved, for this 3 minutes is not worth it. Like, I'd almost say go and have a look at the merit question and see if you could rather spend that extra 2 minutes in the merit question. Because in this question, right, you make one minor mistake and you don't even get the full achieved. And that's what's so frustrating about these Trapezium rules and Simpson's rule questions. And every year they have one of these questions. And every year I say the same thing. I hate them. And just skip that question and go straight to merit. Unless you're like, man, I just want to pass this paper, then make sure you get this question correct and double check your answers, all right? How are you guys doing in the chat here? Are we okay with that? Yeah, definitely, Ravine. Like, you know, if you think about it, you know, you don't want to be wasting, like, something like this question. I don't know, I just get pissed off because it's like all it is like punching a bunch of numbers in a calculator. You know, there's literally no thinking here. There's no tricks, there's no application, nothing. It is just putting numbers in a calculator and figuring out what the answer is. So I don't think I need to spend any money. I'm sorry, Charlotte. I really am, but it's just like, look, even you, I think by the time you get to like the exam, you would have done some of those merit questions and you'd go, oh, this is just so lame. It's the same question again and again. But anyway, let's go to this one here. All right, so what I'll do is I'm going to give you guys about maybe 3 to 4 minutes on this question. Have a go, and then I'll see if there's any other kind of comments in the... yeah, like that. I agree, Pyro. It's just like, you know, I've done it every year. I do this question, and every year I just get frustrated with that particular one. Maxwell, in all honesty, I don't know, even if it's open book, I'm trying to think how it's going to help, because I actually find open book exams quite tough, especially in uni. I remember there was an open book exam and we all like, oh, it's an open book one, it's going to be sweet. Mate, you got to have your notes organized there, because you really got to have your stuff organized if you're going to go to an open book exam. So make sure you have all the notes in the right place, and you know, because don't spend time looking for your looking for how to do things. Eels and storm. So remember, guys, differential equation, you want to bring the x, all the x's and the dx to one side, the y and dy to the other side. Just to give you guys a bit of a Ravine. No, last year I saw some weird ones. They actually had like 2 excellence questions in one of the calculus papers. I think it was differentiation, if I remember correctly. I thought that was weird. Like, you know, they never actually have like 2 E questions, because normally they have like 1 excellence question and then they call it like E8. And if you get like a minor error, you'd get an E7. And so the strategy would be like, if you can do 1 excellence question and those other merit questions, you can get a maximum score of 20, because you can get 1 M6, 1 M6 and an E8 that gives you 20, which is pretty close to excellence in some papers. Like 20 is excellence in some papers. So the safe one, of course, is always answering 2 excellence questions and getting that merit. But yeah, it all depends on how you manage your time and how you find the questions. Right, guys, I'm gonna start doing this one at the moment, unless you guys need a bit more time. Let the pen go. All right, let's actually start going through this question here. Okay, so with question 3C, what we've got is a differential equation. So with differential equations, the first thing you really want to be doing is you want to bring all the y's to one side and all the x's to the other side. So what we are talking about is we've got dy dx equals sec squared 2x over y. Cross multiply this, so we're going to get y dy equals sec squared 2x dx. All right, with that in mind, we're going to integrate both sides. When we integrate y, we're going to get y squared over 2. Now when we integrate sec squared x, you're going to get tan x, or in this case you're actually going to get tan 2x. But of course, remember, you have to divide by the differentiation of whatever the bracket is. So in this case, it's going to be 2. And of course, it's a differential equation, so don't forget the plus c. Now, doing it up to this part in this particular question is actually going to get you an achieved. So let's go and try and figure out what we need to do to get a merit. Now it says, given that y is 2 when x equals 3 pi over 8, find the values of y when x equals to pi. So it's a 2-stage question, right? So the first stage is we actually need to figure out what c is. To figure that out, we actually have the x and y value, because our x value is 3 pi over 8 and our y value is 2. So we're going to use this first to try and figure out what the c value is. So our equation is y squared over 2 equals tan 2x over 2 plus c. Now y is equal to 2, so we've got 2 squared over 2 equals tan 2 times 3 pi over 8 over 2 plus c. Now 2 squared over 2, that's 4 over 2, so we're going to get 2 equals, now tan 2 times 3 pi over 8. I kind of need to do that in the calculator. So making sure that your calculator is actually in radians. So we're going to go shift setup, check that the angle is in radians. Good, that's fine. Next up, we're going to go, let's just get rid of all of this. We're going to go tan of 2 times 3 pi over 8. Cool, so that's actually equal to -1. So what I've got here is -1 over 2 plus c. And if I rearrange this, I'm actually going to get c is equal to 2 plus a half. So we can say that c is equal to 2.5. Now once we figure that out, next step is to actually substitute x into the equation. So our equation, well, x is equal to pi. We need to figure out what y is. So we've got y squared over 2 equals tan 2 pi over 2 plus 2.5, because 2.5 is the c value. So with that in mind, I've got y squared over 2 equals tan of 2 pi. So tan of 2 pi is equal to 0. So we've actually got 0 plus 2.5. So y squared is equal to 2.5 over 2. Cross multiply, I've got y squared equals 2.5 multiplied by 2, which means y squared is equal to 5. So therefore I can say y is equal to plus or minus square root of 5. Now it's really important that you put that plus or minus, just because I know in the answer schedule they actually say plus or minus not required, but when you're working with calculus, especially at this level, it's just good habits to kind of put that plus or minus in, because certain questions you're going to get where you're going to need to use that plus or minus. And so it's always a good habit that when you take square root of a number, you actually put down plus or minus. So getting to that final answer is going to give you a merit. Graph the correct separation of both sides. Yeah, so that's pretty much it for this question, guys. That's a merit question, and you need correct solution with correct integration after correct separation of both sides. A lot of things happening there. But yeah, that's what you're getting for a merit. Yeah, differential equation is more towards the end, Pyro, so it'll come though. Yeah, Jung, normally they have like 1 excellence per question, so I guess William Gao wanted some attention. The thing is, like, integration is a funny, like, I don't know, I actually enjoy complex numbers a lot, but integration is just like one of those papers like where you need to learn how to differentiate to do integration. So when people actually tell me I like integration more than differentiation, I'm like, how's that even possible? Because you need to know differentiation to get to integration. But you know, I guess it is what it is. So let me know, guys, if you have any other questions in this. Otherwise, I'm happy to kind of move on to the next question. Charlotte, it depends on which one you find easy, because like, I mean, some years I've found complex numbers quite challenging, some years I've found differentiation challenging, so it's really you know, it depends. Krishar, no, it's not. It's actually timed pretty well. It's not too bad. But like, look, I spend like, maybe I'll do like one session before you guys' exams where I give you guys some strategies on how to attack questions, because there is a bit of strategy on maximizing your grades, right? Like if you think about it, like sometimes you look at an excellence question and you're like, oh God, I got no idea of how to do that excellence question. That one, you have to make sure you get those 2 merit questions correct for an M6, right? Because that's the, like, getting, like, if you think about it, to get a merit in these papers, you only need to answer 3 questions. Like, this is a merit question. If you answer like 2 more questions like this, guess what? You've got a merit in this paper. Yeah, Cherry, that's completely understandable, and that's one of the reasons why, like, with especially with integration, if you guys remember, there was a question we did yesterday where I just used the graphics calculator because I was like, well, I'm not going to sit here wasting time on solving simultaneous equations or anything like that. I just want to get on with answering the rest of the questions, and so I'm just going to take shortcuts as much as I can. To get E21, you only need to answer 3 also. Yeah, that's true. Yeah, it is true. Well, yeah, answering 3 with minor errors, because if you get all 3 excellence questions correct, you're going to get 24. Anyway, guys, let's go to the next question here. And this is possibly one of my favorite questions because it has long division in it. So I am going to leave it up to you guys for here. Have I missed a point? No, I have not missed a point. I was like, what the hell is happening here? So I'll go through the answer at 8:30 for this one, because in this one they're not actually giving you the x intervals. So you kind of need to, what do I say? You kind of need to go through the y, use the y coordinates to figure out what the x coordinate is. A little hint for you. And again, you can use a graphics calculator to get the points, guys. So remember that as a shortcut, all right? I know people forget it. Yeah, y is equal to 1, and the second interval y is equal to 2. So we need to kind of figure out what the x values are. Sorry, I know that it's quality is a bit shocking. I don't know why it does that all the time. Yeah, King, this is a merit question by the looks of it. Yeah, it is a merit question. It's because of its long division, right? So, no. This is definitely a merit question. This is not, even in the older exams, I don't think this is an excellence question. (2020) question 3E. Is that for calculus, Eric? Like what? Integration? Yes, I do, Krishar. There is some long division videos in, I think we do that in complex numbers. So if you have a look at complex numbers playlist 2014, you will see you'll see long division. I've done it before. Eric, I've already done a video for it. Did you watch that, or you still need some questions answered? because I'm sure I did that last year. But anyway, look, I'm just going to go through this question. Yes, you can use substitution. Absolutely correct there as well. You could do that. That could also work as well. So in this question, like I said, I need to actually figure out what these two values are here. So let's try that again. I've got to record. All right, so with this question, guys, what we need to do is we actually need to figure out what the two x intervals are. And like I said, you really don't want to be wasting time trying to substitute y and then rearranging x and all of that. Go straight to the graphics calculator and pull out the points. How do you do this? You go into menu, click on graph, and we're going to actually plot this graph. So in this case, we've got 3x minus 2, and that's divided by x plus 2. So there's the graph. So what you can do is you can click on GSolve and go into this little F6 button, which gives you further options. And you can actually do something called xcal. So xcal basically means it'll ask you for the y value. So I'm going to put down 1. And as you can see, the x is equal to 2. Then I'm going to do an xcal again. So GSolve, F6, xcal. And this time I'm going to put y is equal to 2. Press enter, and that's giving me x of 6. Okay, so as I said to you guys before, I don't like to waste time with these types of questions. What do I mean by that? I want to know what my answer is already, right? So I'm actually going to do that first in the calculator. So I'm going to go to run menu, the original, just the normal one, and I'm going to go to option, calc, and I'm going to click on integral, and I'm going to put this integral straight away. So I've actually got 3x minus 2 divided by x plus 2. And my two intervals are between 2 and 6. So when I actually do this, I get 6.455 as my answer. All right. So with that in mind, I'm going to keep that in the back of my head, or actually just leave it in the calculator, because I know that's what my final answer is going to be. All I need to do now is just to show the integration aspect of it. So I've got 3x minus 2 over x plus 2 dx, and this is between 6 and 2. So as I said to you guys before, you guys can actually do long division for this, or you could do u substitution. Now I'm going to do long division because it's literally one step here. So I've got x over 2 and 3x, x plus 2 and 3x minus 2. I've got to multiply by 3. So 3 times x is 3x. So that's that. And then 3 times 2 is 6, which happens to be that. Now I need to subtract. So 3x take away 3x is 0. Negative 2 take away 6 is negative 8. So what I can actually then do is I can rewrite this as integral of 6 and 2. And I'm going to get 3 minus 8 divided by, actually I might actually do it like this, 3 minus 8 over x plus 2 dx. So the next part is I need to integrate 3, and I'm going to get 3x. Negative 8 over x plus 2 will integrate to 8 ln of x plus 2, and I don't have to divide, I don't have to worry about any denominator, because x plus 2, what I mean by this differentiation of this is 1, so that's why I don't really need to worry about it. And I know that this is between 6 and 2. So what I've got is 3 times 6 minus 8 ln of 6 plus 2 minus 3 times 2 minus 8 ln of 2 plus 2. Of course, I'm not going to actually put this all in the calculator because I already know what the answer is and I've already worked it out. So I'm just going to put that as 6.455. Grades wise, this final answer is worth a merit, and correct integration is actually worth achieved. So you need to get to this line here to actually get an achieved. Right, how do we go with that question? Use substitution, short division. Might need to have a look at that question again, Eric, but I'm probably not going to have a look at it tonight. I told the guys earlier, I'm like, I'm like on final fumes at the moment. I'll do this one last excellent question and I'm gonna go get some sleep. Pretty much Jeong. So that's what I've done here. Like they just want to know that you know how to integrate. The rest of it you can just do that in the calculator real quickly. Even the long division stuff, it's like optional, right? You don't really need to show the working out for it. You can kind of just like, I mean, if you, some people use something called synthetic division. You could use U substitution. You can do a whole lot in it. I'll have a look at it again, Eric, because I can't. Yeah, off the top of my head, I can't actually remember. If you guys are okay with this question, let me know, and then we can go to the final question for the night. Ah, kia ora te. I believe that's the first time that's actually been said in one of my streams. We're good? Cool. All right, let's go to the final question for the night. And of course it hasn't synced. So I'm gonna give you guys a good 7 minutes for this question, right? So nice long time for you guys to do this question. Just an annoying question, this one, more than anything. It's a bloody annoying proof. Ugh. Oh, you have no idea, Pyro. Like the last 5 days has just been like crazy, man. Like, because I've been doing Father's Day presents at the moment. So part of the store is I've been making Father's Day presents, and so I just had order after order after order, and I'm like trying to balance school, YouTube, and the store. It's taxing, man. It's taxing. I'll show you guys. I'll show you guys. This is what I've been. This was the Father's Day thing that I did. That one there. Basically, I take out 3 photos and then make them into a little present. It was good fun. You know, I enjoyed it. But what I didn't realize was how many people actually wanted to kind of like order it, but each one takes me like such a long time to do as well. Yeah, Krishar, I have my own store. I have my store because it's like I kind of do that as a hobby. On top of this, I really should take some time off, but I started this year, Krishar. I started these. Hang on, I'll show you guys a bit more stuff. That are some of the things I've worked on. So I do things like this. Little cake toppers, signs, little labels, and more cake toppers. Lots of cake toppers. Then I did this for my, which one did I do for my son? Did that for my son. This is where it all started. So yeah, just do that as a hobby. Anyway, stop distracting. Get back to work. Nah, man, I'm getting burnt. I'm getting burnt badly. Like I, I get, I like making stuff because it's like it keeps me thinking. But I get bored making the same stuff, so I just like making different things. So every now and then I'd ask people like, oh look, thinking about making this. Do you guys want me to try and make it? And then I'll make like a couple of them, and then I'm good. I'm happy. I'm like, oh yeah, made it for someone. Off you go, leave it. And then like down the track, someone will come and say, oh, can you make it for me? I'm like, oh yeah, all right, yeah, can do that. But it's not as challenging as the first one. Uh, Pyro prefect work is hard, man. Like jeez. I see some of what us teachers expect you guys to do with prefects, and like, cause we have like student leaders as well, and I look at some of the student leaders and I just feel, man, that's a lot of work for you guys. No, I just haven't gone for a run lately, and that's like that kind of sucks, cause actually today was 1st of September. Damn, I'm supposed to start a challenge. Forgot that. Almaston Junior College. I was teaching angles in a straight line today to my kids. That's how exciting my maths is at school. Long, Krishar, long. None of these short distance. Like my ideal run is like, you know, like I actually really enjoy running half marathons. Like that's good because it's like it's a bit tiring, but I prefer like, if I go out, I want to go for like a 10K run. You have no idea. Like, look, seriously, teaching you guys integration is actually so much more easier than teaching year 8's angles on a straight line and area of a circle. My God, I try to teach area of a circle. I struggle to teach area of a circle to my year 8's because they're like, what's pi? Why? And I'm like, but pi is pi. Pi is 3.14. Absolutely. On the money there, Pyro. Krisha, you'd be surprised. Like, I used to think I could never do a half marathon. And then I started training for a full marathon. And when I did the full, I was like, halves are like so easy. Um, no, I'm talking Pyro. Even in school, right? When I used to work with my own kids, I found that kind of teaching like straight line graphs and stuff like that was much more interesting than yeah, area of a circle. But I enjoy the I mean like this is the first time I've done this many live streams in a year. Normally I do like one every second day and I kind of like just take it slow. But this week I wanted to try 5 just to see what it'll be like. But to be honest, it's tiring, but I enjoy it. It's good. Yeah, King, welcome to the proof world, eh? And I think that's why I started enjoying maths so much as well, because I was like, I could always count on proofs. Because when the proof question came, man, it's on. Like, it's either you're getting this answer, or you don't. That was it. Just looking at seeing how have they done like different methods here at all. All right. The convos are more interesting. Is he twitching? Just waiting for my dog to make his customary announcement that he is about to go bark. No, he's not. Okay, let's get back to it. Final question, and then I can finally go back to sleep. Pyro is right. Yeah, yeah. All right, all right, all right. So, last question for this particular paper, guys, and also for us. Okay, so what do we got? We've got both of these curves here. First curve is this yellow one here. That's going to go like that. So that's our yellow curve there. Then we've got y equals k, which happens to be here. Now, what we can kind of assume is, because that's the origin there, we know that this part right here is going to be equal to 0. And here we go. The customary dog bark will be happening very shortly. But we actually need to figure out what this value is. So to figure out what this value is, we actually need to put both of these equations equal to each other. So we've got kex squared equals to k. And then, yeah, we pretty much leave it like that and we try and figure out what x is equal to. So I've got k squared e to the power of 2x equals k, because, you know, when I do powers of powers, remember that k has a power of 1. And what do we need to do next? We're going to get rid of the k squared to the other side. So e to the power of 2x is equal to k divided by k squared. So in other words, you're going to get e to the power of 2x is equal to 1 over k. So far, so good. Next, we need to work out what the take logs for both sides. So we're going to get ln of e to the power of 2x equals ln of 1 over k. Now ln and e kind of disappears. So we're going to get 2x is equal to ln of 1 over k. And then we can say that x is equal to ln of 1 over k, and the whole thing is divided by 2. So all we really discovered here is just this particular point, ln of 1 over k over 2. And unfortunately, this gets you nothing because you've actually done no integration. All you've done is just put two equations together to get an x value. So, you know, even if you get up to this part, you don't actually get an achieved. You can get an achieved for integration of the equation, but like we'll do that next, right? So we can actually work out the area because we've got the two zones here. We can actually do the whole between 0 and ln of 1 over k over 2. Now, I don't know if you guys have actually watched some of my videos. We do the whole top minus bottom to find the area between two curves. So that's what we're going to do here. So the top is the yellow line, which is going to equal kex squared minus k dx. All right, so with that in mind, now we need to actually kind of expand that bracket before we kind of do anything further. So we've got 0 ln of 1 over k over 2. We've got k squared e to the power of 2x minus k dx. All right, so let's integrate this. Now k squared is a constant, guys, so we don't need to worry about it. It is still going to be k squared e to the power of 2x. But of course, I've got to divide by the differentiation of the power, which happens to be 2. And then I've got minus k, which integrates to minus kx. Now all of this is between 0 ln of 1 over k over 2. So I'm hoping it's good so far. Now in terms of grades, I think by the looks of it, if you were to get correct integration is going to get you an achieved. So this line here is going to get you an achieved. Correct integration with correct limits substituted in is going to get you a merit. So the next line, you're actually going to be looking at a merit because you got k squared e to the power of 2 times 0 over 2 minus k times 0 minus, now here's when things are going to get really quite ugly here. So we've got k squared e to the power of 2, x is equal to ln of 1 over k over 2. All of this is over 2 minus k times ln of 1 over k over 2. So I just want to check that I've actually got everything right here, because between 0 and ln of k over 2, everything is looking good so far. Let's just check that I've got everything right here. K squared over 2 minus k, that's looking good. K squared over 2 ln of 2, yep, that's all looking good. Minus why am I getting this? Give me a second, guys. I just want to check the answer schedule and my answers. I feel like there's something not right here. How do they get k squared over 2? Yeah, looks the answer schedule looks wrong, Salty, because they've got a k squared over 2, and I'm like, how the hell did they get a k squared over 2? The 0 comes from the sorry, Jiyoung, I'm just going to go back to that. The 0 actually comes from the origin there. So if you look at it, there's a little circle here that says that it's origin. That's where we get the 0 from, and we always put the higher number at the top and the lower number at the bottom. Yeah, but then what's the final proof? There is a ln of k. Oh, yeah, okay. That's not too bad. Okay, that's fine. Let's just keep carrying on then. Yeah, because in the answer schedule, they've got a k squared, which is weird. Right, so what do we got here? E to the power of, let's kind of start getting rid of some of these elements. So we've got e to the power of 0, which equals to 1. So we've got k squared over 2. Minus k times 0 is 0, so that's fine. So we've got minus. Now here we've got k squared. Now the two 2's cancel out each other. I'm talking about these 2's here, which means I'm left over with e to the power of ln of 1 over k over 2 minus k over 2 ln of 1 over k. At this point, I've got k squared over 2 minus, in the bracket, I've got k squared over 2. Now e and ln cancels out each other, which means I'm going to get multiplied by 1 over k minus k over 2 ln of 1 over k. So next I'm going to expand, get rid of the k squared and k, which is here. So I'm going to end up with just k over 2 minus k over 2 ln of 1 over k. Keep carrying on. So I've got k squared over 2. I'm going to take out the brackets. So I've got minus k over 2 plus k over 2 ln of 1 over k. Now my proof should be, what's my proof? My proof should be, I'm doing this here right now. It should be k over 2 bracket k minus 1 plus ln of 1 over k. So all I got to do here is take k over 2 as a common factor. Then I'm going to get k minus 1 plus ln of 1 over k. I have to say, like, I mean, I know it's quite ugly in terms of like lots and lots of substitution here, but you actually get merit at this point right here just for substituting. And then by the looks of it, if you get the final part, correct solution with correct full equations, sorry, correct solution with steps clearly shown, gets you an excellence there. So it's actually not a bad question, to be honest. And I think about all 3 excellence questions that popped up in this paper, it's not too bad. Like, I mean, you could have actually attempted the excellence question straight away for those high risk guys. yeah, it is possible to actually get those 3 questions and then be off on your merry way with 24 points. There we go. That's basically it for this question, guys, and I think that's us. How are we going here for any questions here? Let's have a look. Do I mark any NZQA exams? No, man. I actually like enjoying my like during the break time. I actually enjoy it. I've thought about it, Krisha, but like every now and then I'm like, nah, it's just not. Maybe next year or the year after. Jung, hopefully we answered that question for you. How do we know that ln is a lower number? Well, because it's a negative number, buddy. Like there's only one point where that intersection is going to happen, and that's actually before the 0 there, and so that's why we know that it's going to be the lower number. No, because k could be a, like, look at this. It's not negative ln of 1 over k. It's just 1 over k. Because if you have k as a number, right? Like, watch this. If I do ln of 1 over 10, it's automatically going to become a negative number. Because the way ln numbers work is that if ln of 1, like, look at this. ln of 1 is equal to 0. So if you think about it, anything like ln of 1 is 0. So when you have like 1 over a number, that usually means that it's a decimal point. Like it'll be between 0 and 1. So if I take like ln of 1 over 2, sorry, I should put that ln of 1 over 2 in a bracket. So if I go ln of 1 over 2, it's actually going to be a negative number. So that's why we don't actually put a negative in for our limits there. Yeah, thank you, Ayush, for pointing that out. Yeah, visually is also there. That's another clue, but we don't need to worry about the negative sign for this. Yeah, it is a pretty straightforward question, because I thought it would be a little bit longer than that. Is it? Yeah, I guess you could kind of do that. King Zag, yeah, I understand what you're trying to do there. Put k to the power of -1 and then bring the -1 through. It's an interesting question, Charlotte. I would actually say to you guys, like, if you guys are doing level 3 at the moment, you need to kind of create, what do we call it? You kind of need to start creating the timetable now, right? Because it's just need to put down like how many exams you're doing, how many externals you're doing, and then based on your externals, you'll kind of divide your time up. Like I would actually say to you guys, like the best way to plan is like do past exam papers, man. Like just like have some study notes, do past exam papers, and if it means doing some of those exam papers more than once, that's absolutely fine. Like when I was actually preparing for my calculus exam, the way I did it was I pretty much did a lot of practice exam papers. Like I just did practice exam papers again and again and again, because sometimes I'll be like, oh, I don't get this question now. Then what I'll do is like I'll wait till like a week again, and then a week later I'll come back and try that question again. And then I'll kind of go, oh yeah, actually I remember this from last time, and so I kind of just do that. Have lots of breaks. You know, like you can't really study for like 3 or 4 hours. Trust me, it doesn't work, because what you need to do is like kind of get into that habit of, I'm gonna do work for like half an hour, take like a 10-minute break, half an hour, 10-minute break. Definitely works. Just trying to have a look. How many E marks for E8? I guess, yeah, it's just one excellence question that comes every question King Snail, so you're probably looking at 3 excellence questions. Yeah, that's actually a really good point, Raveen. I would actually encourage you guys to actually follow that. It's like don't just watch my stuff, don't just listen to my stuff, but actually write like write the questions down, or like get some printouts of the question and actually keep writing those answers down. All right, watching these videos, just watching them is not going to help. This is like a supplementary thing. All right, don't make it into a main thing. So what you should be doing is like work on the question, but then have me explaining on the side. It'll kind of help you guys understand, but don't just be like, oh, I'm just going to watch the video and that's my study. That's not going to work at all. Pyro, I've actually got like a 12-hour playlist that's worth watching for complex numbers. If you have done it before, it's a really good reminder that you can actually watch it again, and you'll get the hang of it pretty good. No, happy to help, Jiong. That's you know, it's the whole point of this. It's, you know, it's to kind of like give back what I can when I can. So guys, next week what we're gonna do is I think on Thursday we will probably do like a, what are we at next week? Because it's September 1st, September 9th. So we probably do like, I think, yeah, we'll do a Thursday, but it's gonna be like a merit. I think some of the guys yesterday were talking about like just merit questions from like one exam paper. So we do all 6 merit questions from one exam paper. So we'll just kind of go choose an exam paper, like, I don't know, complex or differentiation or integration or whatnot, and then you guys can pick like which paper you want to go, and then we'll just kind of go through those questions, just power through them, eh? But yeah, normally I'd love to sit and have a chat, guys, but I've got to call it a night, eh? I'm gonna actually go get some shut-eye. One of those days where I need like 9-10 hours of sleep so I can function on 5 for the next 6 days. Yeah, true that. Right, have a good one, guys, and then go to Rarotonga. That's my secret hideout, man. That's the only place that I can go where I don't get work, because I don't get Wi-Fi and I don't get anything, so I actually enjoy my holiday. Last time I was at Rarotonga, I actually saw a turtle in the wild, and I was just me and the turtle swimming out in the ocean. That was pretty insane. That was such a good memory. It's such a good memory. I actually want to. I'm gonna find it. No. I'll find it. I'll show you guys. I don't know if this will work or not. It is. That was me. There you go. So I was like looking for like little fish here and there, and then next thing you know, I look up, and right there, see this turtle. And yeah, I was just swimming along with this dude. That was good fun. Thanks for the memory there, Ravine. But the last time I was in Rarotonga, that was pretty cool. Caught up with that little turtle. Jerry, it's all good, man. Like, well, I shouldn't really say man. Like, I don't know what your pronoun is. Just doing what I can, right? So no, I do want to go back to Rarotonga. I definitely want to go back. It was so cool though. It was so cool, right? Like, it's like it was. Yeah, it was just me and the turtle. And the thing is weird because like, what is it? September right now? Is it September 1st? September 1st, October? Nah, that was in November. Like 10 years ago, I ended up rescuing some turtles in Mexico. That was good fun too. That was a lot of good fun. Jeez, you guys bring back some good memories from my turtles. I'll see if I can find a photo of that. Where was it? That was in Mexico sometime, wasn't it? Oh no, I can't find it. Why? What would it be? 31st October. Oh, November. That's true, November. I actually met a customs person that that actually knew my stuff, which is really cool to watch. There we go. Here's a picture. Check this one out. That was me saving a whole bunch of turtles. This little guy, we had to go put him in the beach. That was good fun. Right, have fun, Jung. Man, I would love to hear that story, King Zag. That sounds awesome. Yeah. Good luck with your stuff, Jeong, and I'll see you guys next Thursday. Right, guys, I'm out. Yeah. Otherwise, I'll start talking, and that's not good for me. Can keep talking. Have a good night, and I'll see you guys next Thursday. Keep an eye on Instagram to figure out what we are going to do for the night. All right, for Thursday night next week. Catch up, guys. See you later.